Okay, this is going to be a video on the introduction to the atoms and isotopes worksheet. And before we get started with that, I want to do a little review on the periodic table. And let's take a look at fluorine. Oh, sorry. We're going to look at fluorine, but I'm not going to put a box around it because my drawing is horrible. So fluorine, its atomic number is 9. Its symbol is F, its name is fluorine, and its atomic mass is 18.998. But we're going to call that 19 because when we see fluorine, it's going to have an atomic mass of 19. So the atomic number is 9. The atomic number is 9, and that tells us that we have 9 protons and we have 9 electrons in a neutral atom. Its atomic mass is 19, and that tells us that we have 19 protons plus neutrons. So in this fluorine, the fluorine that you would most likely find, if it has 9 protons and 19 proton plus neutrons, that it should normally have 10 neutrons. So when we talk about isotopes, this is what we are going to be taking a look at, the number of neutrons. In an isotope or any atom, we cannot change the number of protons. We cannot change the number of protons. They have things like atom smashers, and if you ever watched Flash, the Flash's building is in it's in an atom smasher, but I'm sorry, the name of it is not coming to me. But the number of protons never change. So when we talk about neutrons, when we talk about isotopes, it is the neutrons that are going to change. Now, some isotopes are naturally occurring, and they're considered stable, which means they'll stay that way for some time. Sometimes they don't. They'll break down right away. And for the worksheet, if we go back to the worksheet, or let's go to the gizmos first. So this here is helium, and if we take a look at the notation, this a lot of times is called isotope notation because this tells us that its mass is 4, its number is 2, and that is helium. Okay. If we add a proton, we change the atom. So we can never change the protons. But if we add a neutron, its mass goes up, but it stays helium. And if we take a look at it, this tells us that it is radioactive. That means that it's not stable. And this is the half-life. That means that if you were to make this, that means that half of it would disappear in 7 times 10 to the negative 26 seconds. So it doesn't want to be that way. And you can keep on making them and they aren't going to want to be there. So here's a stable one and here's a stable one. So helium as a stable element is helium-4. So helium-4 is stable, and an isotope of it is going to be helium-3. So it is sometimes written as helium-3. So this is considered isotope notation, and this is considered elemental notation, or a lot of times we call it isotope notation, because that is going to tell us how many neutrons it has by its atomic mass. Okay, so if we take a look at our element builder worksheet, and I'm not assigning this yet, but to find the stable isotopes of carbon and nitrogen, that's how you'll do it. You'll go into your gizmos and you'll mess around with the size. So if we take a look at our worksheet, getting back to why we started, Here are three isotopes of an element, and this is carbon. And if we take a look at carbon on the periodic table, carbon should be carbon 12. So carbon should have 6 protons, 6 electrons, and 12 minus 6, 6 neutrons. So this one here, that carbon is not, this one is not an isotope. Well, they call them all isotopes, but this one here is a big isotope, and this one here is a big isotope. So the 6 is going to refer to the atomic number, and that is going to tell us protons or electrons. The 12, 13, and 14, those are going to tell us the mass. So how many protons and neutrons are in the first isotope? Well, if it has a mass of 12, it is going to have 12 protons plus neutrons. Okay, so let's take a look at one down here. So uranium-235. Uranium-235. Its atomic number is 92. Its mass number is 235. Its protons are going to be 92. And if it's a neutral atom, if it has 92 protons, it's going to have 92 electrons. So how many neutrons is it going to have? So we have to take 235 minus 92, and remember the calculator is your friend. I just didn't have one handy, and that is supposed to be a 4, by the way. It should be 143 neutrons. And as you go through this worksheet, you are just going to be, for the most part, trying to find it. And when we take a look at, here is your isotope notation. That isotope notation, once again, is where we are going to have our He, and we're going to have our atomic number there. And since it has 2 neutrons and 2 electrons, that means it should have 2 protons also. So it is going to have 4. Okay. Now, because you're typing this out, let's do it typing wise. Let's just do He-4. And the atomic mass will be 4. Okay. And we'll scroll down and take a look if we need to do any more. Once again, here's our isotope notation. Instead of typing it out with subscripts and superscripts, we're just going to go O16. Bingo! Sorry, stupid dad joke. Atomic number, protons, electrons, neutrons. Okay, so as we go through this, hopefully I've done enough of them to help you on it, and you are more than welcome to continue. Have yourself a great day.